So welcome to the channel guys. I hope you all are fine and doing great. So let's discuss this problem today. A problem of the day, GFG, maximum sum of non-adjacent nodes. So move on to the problem. So this is the binary problem. This is a medium problem, but I think it should be a hard problem. I am telling you why. So the problem description states that we are given a binary tree with a value, like it simply means we are given a tree, and what we have to find the sum of nodes that are non adjacent. Like with this one we can take any of this number 1, 4 or 5. With this 2 we can take 1. With this 3 I cannot take 4 and 5 and 1. With this 2 I cannot take 1 and 1. So okay, means we cannot take the same nodes that are connected by a same edge. Like here we cannot take these two nodes, we can only take one nodes from a edge. Okay, that simply means it. Like here we cannot took neither 2 and neither 1 with 11 when 11 is in our sum. So our answer is 11 because it is the maximum. But else, while if we have to find all sum, then here 1 plus 2 can be a sum. Okay, because they don't share an edge, they are not adjacent, you can say more clearly. Similarly here, now what we can do, we take this and both of this, like 6, no sorry, this, this and this, both all these three, and then take in our sum this. We ignore 2 and 3, so we take non adjacent four edges in our sum. Okay, so now focus on the problem. Now we are given this function get max sum and a node of the tree, that is root, and we have to return the maximum sum. So okay, so what we do, we call a function solve, and we return a pair int comma int from it, and we return maximum of the first or second index. Now what is this pair int comma int? Now focus on this solve function. This solve function will take a node star root address of the root node, and it will return this. Like if our r is equal to null, like if our r pointed to this number, this here, the or the from here, if our r is pointing to the right side of 2, then it will return 0 comma 0 because we don't have any sum. Else, while what it is stored, it is in its first index, it will store the sum we can get if we add the value of this particular root node, and the second int of this pair will store the value what the maximum sum we can get if we ignore the value of this particular root node. Okay, so I am explaining you by figure this example. So just focus. So we do for it for left, we do it for left and right. Then like for this 3 we got the sum of this 5 branch, sum of this 2 branch, and for 1 in our L we have the sum of maximum sum yet 2, and in our RG we have maximum sum yet 3. So okay, so in our A we will store the maximum sum till this point, the maximum sum in when we are at 1. Then our pair dot a will store the maximum sum till our 2 including 2. Similarly, when we are at 3, a will store the maximum sum with 3 include in our answer. And in the second part, a dot second include the maximum sum till 2, which does not include 2. Means the maximum sum of these all branches, the branches of the 2, but not include 2 in our answer. Similarly, the second part of this 3 will means the maximum sum of its root of its children, which don't include 3 in answer. So second means we add both second because second means we don't include these 2 and 3, so we don't include these both, so we can include the data of the root. For this if we don't include both of this, then we can include the data of this in our second value. Okay, and in B we will store the maximum of its the maximum sum yet this position, if it is include or it is exclude. Similarly, if it is include or exclude, and we return a comma b. Now I am explaining how it work. Like here, you can see this is a binary tree. I am explaining 100, 4, 4, 1, 2, 10, 20, 5 and 7, 4, 3, 2, 1, 2, 11 and 4. Now here it will get 0 comma 0. Okay, because this condition will work out for it. Okay, so same with here also, same for this, both this for like for every leaf node it will happens. So okay, so the maximum sum it will return is 10 including this comma. If it is excluded, then the maximum sum will be is equal to 10 comma 0. Okay, same for 20, 5, 7, 1, 2, 11 and 4. Okay, now at 1 it has two choices. The first choice, the first choice if this sum is include, and second choice if this sum is exclude. If this sum is exclude, then it has, or it has, I am showing you, then it has the sum, it can include the sum of these all edges behind it. If there are more edges, it can add those edges also. So it is equal to 30. 10 plus 20 is equal to 30, and 1 is the sum include it. So it does not have any other edge after it, unless we will add the sum of those edges in this one. Okay, same is here. We return 5 comma 0, 7 comma 0, and here 2 comma 7 and 5 12. Same with here 1 2 and 1 and 2 3, and the sum of this is equal to 3. 11 and 4, 11 and 4 15 and 2. Now the main function will happen for this node. Okay, now I am explaining what main function will happen. Yes, you can see. Now for this 4, what we are doing for this 4, if we are including this in our answer, then what can be our answer? The second part of it, if we will add in second part of this, like 30, 12, because 30 and 12 are the sum of these all. So we can add this the sum of these all in our 4. So 4 plus 30 comma 12 is equal to 40, 46. And second, if we exclude them, then we have to put out the maximum sum among all edges yet. I will mark it with some other color. Yes, green is perfect till here. Why? Because the number we are returning here will add in it. Okay, will add in it, and in it we can add any number among it, because for this 100 we can add the sum of these edges as well as these edges. Now but we cannot add the sum of both of these edges, because now if we add both of these edges sum, then it will give us the sum of two adjacent uh, as is. Okay, I don't find it where. So we have to find the non adjacent node sum. So okay, so we cannot add the sum of these both. So but we can in 100 we can either add this or yes, either add this or either add this. Okay, so now what we did, what we return in our here, what we return here we return the maximum of this level or this level, the sum of maximum of this level and this level. The sum maximum at this level is 2 plus 1 is equal to 3, because it cannot include the sum of this level, and the maximum sum of this level is 30 plus 12 is equal to 30 plus 42. So among the maximum on both of these we will return 42 here. Okay, similarly for here, if 4 is include in our answer, then if 4 is include, then we can add it with this 3 and this 15. Then 15 plus 3 is equal to 18 plus 2 is equal to 22, comma, if this 4 is excluded, if this 4 is not included in our answer, then we can add the sum of either this or sum of either this, because we have to add with this, we have to add the second part of this, we will add with this 100. So either we can add this as well as this, but not both. Okay. Okay, so we will return the maximum of this level and this level. Maximum of this level sum is equal to 15 plus 3 is equal to 18, and the sum of this level is equal to 2 plus 3 is equal to 5. The sum of this and this. Okay, 2 plus 3 is equal to 5. So we will return 18 here. We will return 18 here. Okay, so now for our 100 we have choice. So in 100 we have choice if 100 is included. If our 100 is included, then answer can be 42 plus 18 plus 100. And if our 100 is not including, then a sum of these two edges, then answer is equal to 46 comma comma not comma plus 46 plus 22, and it will return it from 100. We will return the sum of this, that is 42 50 61 60, and sum of these two 68. So 160. So this 160 will be our answer, and we get the maximum sum of 160. How? Add 100 and add all of these branches. Add 100 and add all of these branches as well. Okay, so these branches and these branches, all the leaf node we will add. Okay, so if you understand it, I hope you all understand it. Now move on to the problem. Compile and run. Try to submit it. Yes, you can see this is also a very good case. You can also try it. I tried. You can see the wrong submission. I found a case, a very long, in a very long test case, my answer got not submitted over like 500 notes. Then I find out this base case where my answer got struck. So you can see now I have passed all 231 case, and the time complexity is very good because I am iterating a single node only once. Okay, so this is for this video, guys. I hope you like it, and if you don't understand, then just try run it once. And I am telling you, try run it with this case also. This is also a very good case. If you don't understand what I did here, then try it with this case. I am again saying you. So I hope you like it. If you like it, then please subscribe it, and for more amazing content of coding, I will also upload LeetCode daily challenge and GFG challenge regularly. So thank you for watching this, guys. Thanks a lot.